I want to begin by taking a quick look at what we've discussed so far this year. Unit 1 was focused on the real number system. We categorized numbers based on their properties, converted rational numbers into various forms like fractions, decimals, and percents, and we reviewed how to perform calculations with real numbers. Later in the chapter, we learned about powers and roots and how they can be used to solve problems. We also used our knowledge to estimate irrational numbers and work with numbers in scientific notation. All of these lessons were focused on numeric expressions or expressions containing numbers and operations. In Unit 2, we will learn about algebraic expressions and equations. This means we'll be learning to evaluate and simplify expressions that contain variables and learning how to use algebraic properties to solve linear equations. Today, we will focus on algebraic expressions. More specifically, we will review important vocabulary, evaluate algebraic expressions, and simplify algebraic expressions. Some of this information should be a review from 7th grade. Before we begin, I want to remind you that this lesson is completely self-paced. Feel free to pause, rewind, or fast forward this video as needed. If you pick up on things quickly, you may want to pause the lesson, attempt the remaining example problems on your own, and then resume the video to check your answers. Do what works best for you. Let's begin. So we're starting section 2.0. Algebraic expressions. Our lesson essential question is, how can algebraic properties be utilized to simplify expressions? Again, we're going to start with some basic vocab. So first vocabulary word is variable. A variable is a letter or symbol, really could be anything, that is used to represent an unknown value. Next, we're looking at algebraic expressions. It's also known as a variable expression. These expressions consist of numbers, operations, and variables. To discuss the next few vocabulary words, I want to provide an example expression for you, something very simple, 5x plus 2. Okay, so for algebraic expressions, we have different vocabulary words for all the little parts that make up that expression. So the first one is, if you look in the bold, is called terms. I'm not sure if you remember this from 7th grade, but terms are the parts of the expression that are separated by addition or subtraction. Running out of room. All right, so if you were to look into any definition in a math textbook, they actually tell you that terms are only separated by addition. This is because subtraction could always be converted into addition by adding the opposite. Remember, keep, change, change. If we look at the expression that I've written down as an example, this expression has two terms, 5x and 2. Each term has its own name because one has a variable and the other does not. The terms which include the variable are called variable terms, so that goes right here. I love how mathematicians name things so logically. The term with a variable in it is called a variable term. Go figure. So maybe you want to write a little note to yourself for later. I'll put 5x is the variable term. All right. If we examine variable terms further, we'll find that there are actually two more vocabulary words here. So I'm going to write a note to myself in the margin. I'd like you to follow along and do the same. I'm going to copy my variable term here and label each part of the term. We already know that the x is called the variable. But can you remember the name for the number in front of the variable? There's a very specific vocabulary word that we need to know here. Perhaps you remembered, perhaps you did not. It is called a coefficient. It's important to learn this vocabulary because as we discuss Unit 2 and every other unit throughout the year, we're going to be using this vocabulary. Okay, so we talked about the first term, which was 5x. That was our variable term. That variable term has coefficient 5 and variable x. Now we'll move on to the term that does not have a variable. That is called a constant. You might have heard that vocabulary word in science class as well. Let's take a moment to check your understanding of the vocabulary you just learned. How many terms does this algebraic expression contain? If you said 5, you'd be correct. Remember, terms are separated by addition and subtraction. Imagine this expression on a slip of paper. I could take a pair of scissors and snip before each addition and subtraction symbol. Afterwards, the number of slips of paper would be the same as the number of terms. Next question. How many variable terms are there in the expression? The correct answer is 3. They are 10x, 5y squared, and 7w. What is the coefficient of the fourth term? The correct answer is 7. Next, I would like you to list the constants in the expression. The correct answers are -3 and 11. Remember when I mentioned that textbooks only state that terms are separated by addition? This affects how we look at subtraction symbols within an expression. These are indeed subtraction symbols, but we need to think of them as the sign of each term. In other words, the terms in this expression are 10x, 5y squared, -3, 7w, and 11. It may seem strange at first, but if you can transition your thinking to this perspective, it will make other necessary skills in this unit so much easier. Let's try one more. How many terms does the expression contain? If we visually divide the expression into terms, we can see that there are 4. How many variable terms are there? This time there are 2 variable terms. What is the coefficient of the second variable term? If you said -9, you're correct. List the constant terms. This expression has 2 constant terms, -1 and 23. I hope these side examples were helpful. Let's move on to evaluating algebraic expressions. To evaluate an expression means to substitute a given value for a variable into the expression and then simplify. So essentially, when you're being asked to evaluate an expression, you're going to find the value of that expression after they give you a number to substitute for the variable. Something that is very important that you need to remember to do when evaluating is to make sure that you follow the order of operations. You might have learned that the order of operations can be remembered by PEMDAS. This is a good memory cue that can help you remember the order of operations. However, one common mistake that students make if they're using the PEMDAS acronym is that they look at the M and the D and they say, okay, multiplication must happen before division. Students can sometimes do the same thing with addition and subtraction. The truth is that division can be changed into multiplication by multiplying by the reciprocal. Remember, keep, change, flip. And I also mentioned in this lesson earlier that subtraction can be changed into addition as well. Keep, change, change. So when I remember PEMDAS, I like writing it this way. If I write the M and the D together and the last two letters together, then I will remember that multiplication and division are performed from left to right if they are both in the expression. Same thing with addition and subtraction. I'm going to work the same directions that I read from the left to the right. Let's move on to some examples. The directions state, evaluate each algebraic expression using the given values. Number 1 is 5x minus 9 plus 3x, where x is equal to 2. So I'm going to substitute a 2 everywhere I see an x. I like to use parentheses when I substitute, that way I don't lose any symbols or forget anything that's happening in the problem. So I'm going to start by substituting first. Once I've substituted a 2 in for x, I'm just going to follow my order of operations. I see multiplication happening in 2 different places in the expression. I also see subtraction. I see addition. I'm going to perform multiplication first. 5 times 2 will give me 10. I bring down that minus 9. And I also see in here a 3 times 2. I can do that as well since it is a separate term from the minus 9 that's here. So 3 times 2 gives me 6 plus 6. From here, again, I see subtraction and I see addition. I'm going to work from left to right. So I'm going to underline what I'm working on here. So I'll do 10 minus 9, which gives me 1, plus 6. The final answer is 7. Number 2 says 7 plus w over 8, where w is equal to 32. So again, everywhere I see a w in that expression, I'm going to replace it with a 32. So look like this, 7 plus 32 over 8, and that's it. Order of operations, I see addition, I see division, so I'm going to divide 32 divided by 8. So I'll bring down my 7 and my plus. 32 divided by 8 gives me 4. 7 plus 4, 11. Number 3 is 9y squared minus 2y plus 6, where y is equal to negative 3. So this time my variable is equal to a negative number. So let me substitute. I have 9 times whatever y is squared. So 9 times negative 3 to the second power minus 2 times y again. So 2 times negative 3, and I have to bring down my plus 6 as well. So the P in PEMDAS tells me to perform operations within parentheses. If I look at the parentheses, there's only a single number in there, nothing really to do. Next is E for exponents. We do, in fact, have an exponent in this expression. So we're going to evaluate negative 3 to the second power first. Negative 3 to the second power, since that negative is in the parentheses, that's negative 3 times negative 3, or 9. Everything else is going to come down symbol for symbol. I'm going to use parentheses here so I don't forget to multiply. Okay, minus 2 times negative 3 plus 6. Okay, next I'm working left to right. I see multiplication. I'm going to do that next. So I'm going to do 9 times 9, 81. Bring everything else down. Okay, I could have done this multiplication in the previous step, but I decided just to bring it down, make an extra step. So here's something I have to be careful with. There's multiplication in the middle of the problem. There's definitely a negative 3 that I'm multiplying by. But what's the first number? Remember to always look to the left of everything that you work with. So if I look to the left of that 2, there is a negative. So I'm going to see this as negative 2 times negative 3 in my head. That is a minus sign, but remember we talked about that perspective. That's going to be really helpful here. So the 81 comes down, And if I do negative 2 times negative 3, I'm going to get a positive 6. You could also think about it this way. If this is minus and this is a negative, I'm going to get minus a negative, which again is the same as addition. And I do have another plus 6 here, so I'm going to bring that down. Okay, so left to right. And one more problem to do. When I run out of room, I'm just going to make a little arrow just to point to a new column here. 87 plus 6 is going to give me 93. Notice I did not add an equal sign into any of my expressions here. What you want to get into the habit of is if your original problem starts as an expression, it needs to end as an expression. So I'm not going to write anything other than the symbols that are here. Let's keep going. I'm going to zoom here just to make it easier to fit my work. There, looks good to me. So this expression contains a fraction, 2x squared in the numerator and in the denominator x minus 3. And they're telling us to evaluate where x is equal to 5. Again, my very first step is going to be substitution, so I'm going to write that here. When I work with fractions, I like to simplify the numerator and the denominator separately. That helps me keep track of what's going on. So let's take a look at that numerator first. I see multiplication. I also see an exponent, so I know I'm going to figure out what 5 squared is first. That would be 25. I'll put an n for numerator here. 2 times 25 will give me 50. For my denominator, well, that's only one step. That's 5 minus 3, which would give me 2. If I put my numerator and denominator back together, I have 50 over 2, which would give me 25. 9m minus 7 times the quantity, that's what you would say there, of 6m squared minus 3, where m is equal to negative 4. Let's substitute. A lot of parentheses in this one. This is the first example where I do have operations to perform within parentheses. There's multiplication, I see exponents, I see subtraction. So if you have multiple operations happening within parentheses, look at it like a brand new order of operations problem. I would need to take care of the exponent first. In the meantime, everything else here is going to be copied down symbol for symbol so I don't miss a detail. I'm going to leave a spot for my answer there. Okay, so negative 4 squared. Negative 4 times negative 4 would give me positive 16. That's my line. I'm still working within parentheses. I see multiplication and subtraction. Multiplication would be next, so that's where I'm going. Everything else comes down. 6 times 36 would be 96. Remember, you're allowed to use your calculator for these. Okay, still subtraction within those parentheses. $93. I kept those parentheses there because I need to remind myself that there's multiplication going on here on this end. All right, continue working left to right. I see 9 times negative 4. We can take care of that. Negative 36 minus 7 times 93. Multiplication next. This is a negative 7 times a positive 93. So I know there's going to be a minus here because a negative and a positive, when you multiply, become a negative. So I'm just going to write that as minus. All right, so 7 times 93, 651. Lastly, negative 36 minus 651, still going to be negative. So it is a 7, 3, and 5 give me 8, negative 687. After 5 examples, maybe you would like to try number 6 on your own. Pause the video, try it, and then resume the video. See how you did. Our last topic for the day is simplifying algebraic expressions. Unlike evaluating, when we simplify algebraic expressions, there will not be a value that we need to substitute in for the variable. There won't be one available. So, to simplify an algebraic expression, we need to perform all possible operations. This is the first type of problem where we will not get a single number for an answer. So the first thing we need to do is, if there are parentheses, we're going to have to use the distributive property. So under number 1, I'm going to put distribute. Second, we're going to need to combine like terms. The word distribute in English means to hand out. So if I have multiplication on the outside of a pair of parentheses, and there are 2 terms in here, I'm going to hand out that multiplication to both terms inside the parentheses. So if this is A times the quantity of B plus C, after I distribute, it's the same as A times B plus A times C. Similarly, when you have a single number or variable multiplied by a difference, I'm going to distribute or hand out that multiplication to both terms in the parentheses. So this is AB minus AC. This property also allows us to do something called combine like terms, but I do want to review what that is. So like terms are terms in an expression that have the exact same variable or variables, there could be more than one, raised to the exact same power. This is the part that people forget sometimes. To combine like terms, all we need to do is add their coefficients. So in this example, I have 2x squared plus 5x plus 3x squared. there are two terms that are like terms, and there is one term that is not. Because the x in 5x is not being raised to the second power, only 2x squared and 3x squared are like terms in this expression. To combine them, this is 2x squared, and there's a plus in front of that 3x squared, so we're going to add. 2 plus 3 gives me 5, so I now have 5x squared. Because that 5x does not have any like term with it, it just comes down with the rest of the problem. Let's move on to examples. The directions state simplify each expression. Number 1 is 3 times the quantity of x plus 1. Again, I cannot perform operations within parentheses because I don't know what x is equal to. So instead, I have to use the distributive property. So I'm going to hand out that multiplication of the 3 to the x and get 3x. Tiger says hi. And I'm going to distribute that 3 to the 1. 3 times 1 is 3, so I write plus 3. There is nothing else that I can do here because 3x is a variable term and 3 is a constant. They're not like terms. I can't combine them, so I'm finished. Number 2, negative 6 times the quantity of x plus 3. Again, I need to use my distributive property. Negative 6 times x gives me negative 6x, and negative 6 times 3 is negative 18. Now, if I want to save myself some steps, instead of writing plus negative 18, instead, because I know plus and negative is the same as subtraction, I'm going to write negative 6x minus 18. Normally, this would be the step that I write first. Number 3 is the quantity of x plus 2 times negative 3. This time, my single number is to the right of the parentheses, but it's the same thing. So negative 3 times x is going to be negative 3x, and negative 3 times positive 2 is going to give me negative 6, so I'm going to write it as minus 6, negative 6. Number 4, the quantity of 2x minus 3 times negative 4x. This time I'm multiplying a variable term times the difference, so I just need to be careful with my x's here. So if I have negative 4x times 2x, I break it down into two parts. I multiply the number part, so 2 times negative 4 gives me negative 8, and then I think about what it means to write x times x. I'm going to do that up here. Can you think of another way to write this? It's just x squared. So when I multiply 2x times negative 4x, I'm actually going to get negative 8x squared. Finally, I distribute to the second term. So this is a minus 3 times a negative 4x. As stated earlier, I'm going to think of this as a negative 3 times a negative 4x, and a negative times a negative gives me a positive. So 3 times 4x will give me 12x. I'm finished because there are no like terms to combine. So this whole first row of problems is just to demonstrate the distributive property. Our second row demonstrates combining like terms. Okay, so number 5 is 8x plus 3x. These are like terms, so I'm just going to do 8 plus 3 and get 11, and the x comes along. I'm finished. There are 4 terms in this expression. 3 of the 4 terms are like terms. I'm going to combine one pair at a time. So 8m minus m. Keep in mind that the number of m's here would be 1. 8m minus 1m gives me 7m. I'm going to bring down everything else, symbol for symbol, number for number. When I look at what I have left, I still have another pair of like terms. 7m minus 3m will give me 4m. That plus 5 comes down. Since I do not have any like terms remaining, I'm finished. The answer is 4m minus 5. The original problem for number 7 is 2y squared plus 7y squared minus 8 plus y plus 2. The first pair I see are the variable terms with y squareds in them. So I'm going to underline those one at a time. The second pair of like terms I see are a pair of constants. Because I do not want these constants to look like I'm underlining them so that I can combine them with the variable terms, I'm going to do a double underline here. Okay. So I'm not sure if you've recognized this, but every single problem that we've worked on, we've written our final answer with the variable term first and the constant second. That's called writing our answer in standard form. This is going to be an expectation for you throughout the year as well as in high school. So it's good to get into that habit now. When I look at number 7, I see two different kind of variable terms, ones with y squared and ones with y. Typically, what we do is take the terms with the higher exponents and write them first. So I'm going to combine 2y squared with 7y squared and get 9y squared. That's going to be my first term in my answer. Next, I do have another variable term, y. It does not have any like terms to combine with it, so I'm just going to bring down that plus y with the rest of the problem. Finally, constants go last. So I have a negative 8 plus 2, which would give me a negative 6, so I write minus 6. Number 8 is the first problem where we actually have to both distribute and combine like terms. The number I'm distributing here is a negative 4. So what do I do with that 1? That comes down with the rest of the problem. Remember, multiplication comes before subtraction. So while it is tempting to do 1 minus 4, I can't. I have to multiply first. So I'm going to multiply that negative 4 times 1. And get negative 4, so I write minus 4. And then I'm going to distribute that negative 4 to that minus 2x. And again, a minus and a minus make a plus. 4 times 2x gives me 8x. When I examine what I have left, I do notice that there's a pair of like terms here, the first two terms in the expression, 1 minus 4. Because it's a constant, I'm going to write it second. 1 minus 4 gives me negative 3, so I'm going to put it back here. And this is a positive 8x that goes in the front. 8x minus 3. Number 9 is 3 times the quantity of x plus 2 minus 4x. Distribute first. 3 times x is 3x. 3 times 2 is 6 plus 6. Bring down that minus 4x. From here I see I have a pair of like terms, 3x and minus 4x. 3x minus 4x will give me negative 1x, but we don't write the 1 there. Plus 6. That is the most simplified way to write it. Number 10, 9x minus the quantity of 2x plus 3. In this problem, I have to keep in mind that I'm subtracting an entire quantity. I'm going to have to distribute. But what number would I distribute? Certainly not the 9x. It's not being multiplied by that sum. So I'm going to put a 1 here. This is 9x minus 1 times the quantity of 2x plus 3. So that 9x gets brought down. I'm not going to do anything with that yet, but I have to distribute that negative 1 to the two terms inside the quantity. Negative 1 times 2x will give me negative 2x, and negative 1 times positive 3 will give me negative 3. Combine like terms. 7x minus 3. In example number 11, I'm going to have to distribute 2 different times. Notice I have 2 times the quantity of x minus 5, but I also have minus 3 times the quantity of 7 plus 2x. So I'm going to distribute one at a time. I'm going to distribute my 2 to the x and get 2x. 2 gets distributed to that minus 5. So a positive 2 times a minus 5 is going to give me a minus 10. Next is minus 3 times the quantity of 7 plus 2x. So again, I'm going to look at this, because of the subtraction, as a negative 3. So I'm going to do a negative 3 times 7 and get negative 21. So the red is coming from the second distributive property problem. And a negative 3 times a positive 2x will give me negative 6x. From here, I combine like terms. I see a pair of variable terms, 2x, and a negative 6x. That will give me negative 4x. And then I have a pair of constants in the middle. So negative 10 and negative 21 will give me negative 31. Last example. 2x squared plus 4x times the quantity of x minus 2. This distributive property problem reminds me of number 4. We're going to distribute the 4x to the x. Remember, there's a 1 in front of the x, so 4 times 1 is 4. That's not going to change. But x times x, remember from our problem previously that is x squared. Now I have 4x that needs to be distributed to that minus 2. 4x times negative 2 will give me negative, so I write minus, 8x. That 2x squared still needs to come down. This is positive, so I'm going to put a plus here. I do see one pair of like terms, 2x squared plus 4x squared. 2 plus 4 gives me 6, so 6x squared minus 8x. Those are your notes for the day. Thanks for watching. If you like this video, please remember to like and subscribe. If you have any questions or suggestions for another video, let me know in the comments below.